In section 5.3, we're going to begin discussing the complex plane. Now with that, we're going to refer to the x-axis as our real axis, and then the y-axis, this is where our imaginary numbers are going to fit in. So if we have a complex number z that's written as x plus yi, so x is our real value and then y is the imaginary. What we're saying is that we're going over x and then up y, so it's almost like we're doing our rectangular coordinates to this point z right here. Now we could still think of that as polar. We still have our angle theta here, and here's r as our radius, and we know that r is equal to the square root of x squared plus y squared, and we would also think of that as our magnitude. Our magnitude is our distance from the origin. So the magnitude of z would be equal to r. Now as far as that complex number, if we're going to write that in polar form, then we would take this. Now we know x is equal to r times the cosine of theta, and y is r times the sine of theta, and then we have our I value there. So we can write this as, factor out our r there, we have cosine theta, and then we move the I to the front here, and it's sine of theta. So that would be our polar form of a complex number. For this example, we're going to plot -1 plus I in the complex plane and write the expression for z in polar form. So let's start with just our plot. The -1 here, this first value, remember that's our real value, so that's going along the x-axis. So we're going to go back 1 because it's a -1. So we've gone back 1, and then plus I tells us we're going up. So we've gone back 1 and up 1 to this point right here. This does make a right angle, so we know that this value, -1 this way and a +1 this way. So there's plotting that point in the complex plane. Now as far as writing our expression, well, we know that r is equal to square root of -1 squared plus 1 squared. So that gives us the square root of 2. Now we also have here, think about our triangle here, where we have -1, here's our theta, here's a +1. We could set this up as a sine of theta is equal to, now we just found our r value there to be square root of 2. So we have sine of theta is equal to 1 over the square root of 2. That's equal to square root of 2 over 2. And so now we're looking at theta would be equal to 3 pi over 4. Now cosine of theta would be a negative value because we have a -1 here, -1 over square root of 2. So that's negative square root of 2 over 2 here to give us our theta value is equal to 3 pi over 4. And so when we write that now, going back to our polar form that we showed up here, we're going to say that z is equal to r times cosine theta, so I times the sine of theta. So we just determined our values for this. We found r is going to be square root of 2, and we found cosine of 3 pi over 4 and sine of 3 pi over 4. And so that would be our expression for z written in polar form. For this example, we're given z in polar form and asked to plot that as well as write in rectangular form. First of all, based on the way it's written, we know that our r value is equal to 2. That's what we get from this. And that our theta is 30 degrees, which is pi over 6. So as far as plotting that goes, we can go to this point. Here's our r of 2. Here's our theta, which is pi over 6, or 30 degrees. And so we can make our right triangle here, pi over 6, to find this. And we could use that then to find our points over here. We know that this is going to be a square root of 3 over 2 and a 1/2. So we're going over to give us our 30, 60, 90 triangle. Square root of 3 and 1 for those values as far as plotting that point. And for z, we know we have 2 cosine of 30 degrees plus I sine of 30 degrees. And so cosine of 30, we know that that is square root of 3 over 2. And the sine of 30 is 1/2, just like we showed over here. And so now if we go ahead and distribute that 2, they cancel on this side, so we're just left with the square root of 3, and half of 2 gives us 1 there. So then z would be equal to square root of 3 plus 1i, just like we showed here with our triangle, over square root of 3 and up 1. So next we're looking at multiplying and dividing two complex numbers. So we have our first complex number, we're just saying z1, so we have r1 and cosine of our first angle and sine of first angle, and here is 0.2, so second radius, and then our second angle. And so in terms of multiplication, let's say we take z1 times z2. What we're going to do is we're going to multiply the radii, and then we're going to take the cosine of, and we're going to take the sum of the angles. So we're going to take angle 1 plus angle 2. And then the same on this side, we're going to add these two angles here as well. And that's how we would multiply complex numbers. As far as dividing, if I have 0.1 divided by 0.2, we're going to divide the two radii, and then we're going to subtract the angles. So I'll take theta 1 minus theta 2, and same over here with our sine value, theta 1 minus theta 2. So next I'll give you a couple of complex numbers, and we're going to multiply and divide. Okay, so for this example, we're now going to actually multiply and divide these two complex numbers. So we have z and w, and I want you to multiply and divide those. So pause the video, and then we'll check our work. Okay, so here we're going to multiply. So again, I take the two radii, 3 times 5, and multiply them. We're going to take the sum of the angles, so 20 plus 100 on both of these. Now we're going to plug those values in. So the cosine of 120 degrees is negative 1/2, and the sine of 120 degrees is square root of 3 over 2. Now as we distribute, this will give us our answer in rectangular form, where we have negative 7.5 plus 7.5 square root 3 I, giving us our, we know that we're going to the left 7.5 units, and then up 7.5 square root 3 for that value. Now divide. Okay, so here dividing, we take our two radii, 3 divided by 5, and now we're taking the difference between the angles. So we have angle 1 is 20, angle 2 is 100. So 20 minus 100 gives us a negative 80 degrees for our angles. We're going to write that as a positive angle. So here we have our radius with our angle. So this would be an answer in polar form.